Hello, everybody. It's nice to see some familiar names and faces. Welcome to another exciting session with the London Java community. For those who don't know me, my name is Carly Richmond. I'm a senior developer advocate at Elastic and proud member of the London Java community as well. And we're here today for another exciting session with Michael. So the London Java community is organised by a group called RecWorks, who are a recruitment company. So if you are on the lookout for jobs, there are links within the meetup entry to go and look at their latest positions. But they also arrange wonderful communities like this one that we're all here to see today. And there's other communities as well around public speaking, principal engineer and things. So do go and check those out too. But today, we're here today to hear from the wonderful Michael Mirwaldt. He is a Java engineer. He has 18 years experience with Java and 10 years working full-time as a backend developer. He's given 2 talks on Java streams and committed samples to both JMH and JCStress, and enjoys playing improvisational theatre in his spare time, and is a proud uncle of 2 nieces and a nephew. And I have very much been looking forward to this talk on records today. So, Michael, I am going to hand over to you.
Thank you very much for that nice introduction and also for hosting me. And before I can start with my talk, first, if you have some more questions, just put it them into the chat, and I will try to answer them. If you expect it to be more complicated answer, then please ask me at the end so that I don't take too much time longer than planned. Also, please keep in mind that from time to time I will be silent for half a minute or 1 minute so that you can read the code examples and think about it, because listening at the same time to me, that's too much effort and too much workload on your head. And if I'm silent, I still live, okay? And also, first I want to start with a short poll, and from time to time I will also, okay, 1 moment. Okay, I'm not loud enough. Just a moment. So I was not prepared for that, but just give me a moment.
No worries, take your time, Michael.
I think it's easy to fix. Where are the options? Is it now better?
Dan, Nuriel, do you want to?
Okay, because it seems to me that it used my microphone area of my notebook and not the mic here from the headphones. Wonderful.
Perfect.
Okay, and thank you for telling me that, and that it's easier for you to listen to me. My first question is, which Java do you use at the moment at work? You just can add some numbers to the chat while I will check the slides at my view. Okay, wonderful. Okay, some 8s. I must confess that I'm sometimes, unfortunately, also an 8, but it sounds wonderful that there are so many 17s there, because the records were introduced originally with Java 16, and the other features came later. Okay, and I'm at the moment wondering what is cut off my slides. Just a small question for that person who raised that issue. If you look on the button I have got there by Michael Mirwaldt, my name on the left bottom, and on the right bottom, the number of slides. Are they visible or also are they also cut off?
So I can see at the bottom corner 1 out of 31. Yep, so I think you're good. Martin's agreed.
Okay, let's try it anyway. And if there are things that you cannot read because they are cut off, then just tell me again, okay? Okay, wonderful. My next question is, as you can guess, who of you has already used records or does use records? Just a short Y for yes and N for no, please. Okay, wonderful. Wonderful. That's nice. Several Ys. And nobody must be ashamed that if it is no, the answer, I hope after this talk, you will have plenty of good ideas to how to use them. Okay, thank you very much. And thank you for also introducing me, Kali. So I can more or less skip this slide. And I'm privileged that I work for JMH GmbH, a German company, and that give me the possibility to do things like that. And they're always so happy if I mention them. That's why I must mention them here. But all the other things you also already told us, Carly. Thank you. Okay, let's go into the table of contents for this talk. I would shortly tell you what records are for those who have not used them yet or not really looked on it or on them. And we shortly talk about sealed types and sealed interfaces. We just talk shortly about why pattern matching is so interesting and not just only syntactic sugar, at least for me. And then I will give you plenty of examples how to use records in different ways and to solve some common problems with records. I hope there are some tricks for you that will help you a lot if you face those problems. Okay, so first let's start what the benefit of records actually is. You see in line 1 that we define a point as a record, and it's just a one-liner. And on the line from 2 to 17, you see what you actually must write as code or generate by the IDE, or if you are quite lazy, annotated with Lombok annotations that add this code to that class here. I just give you 20 seconds just to have a look on it. I don't think it's very complicated, but you see that it's much less to write if you use records and if you can use records. Okay. The only thing I want to say is that you see here that the getter have not a get prefix in the name. The constructor is as you would expect it. The equals method, the hashcode method, the toString method have just some default implementations. One small point here in line 15 with the object.hash, it's actually, as far as I know, arrays.hash that is used, but according to the Java doc, you cannot rely on one fixed implementation for hash code. They really want to keep the freedom to change it in future if they have some better solutions for that. So line 15 is not exact, but the other, what you see here is quite exact. what you can expect from a pointers record. Okay, next, who of you has used or heard about syntax diagrams, which were for some time quite popular for people who were crafting compilers? So who of you has seen syntax diagrams and knows how to read them? Wonderful, several wise, and I have to explain less. One end, but it's not a problem. It's also not very complicated. Yeah, and in Scala, I think it is quite similar in Scala. Good. To keep it short, what you see here in the syntax diagram is that you have to seal some types. And if you seal them, you might need some more types that implement interfaces, for example, because you cannot seal an interface without permitting it to some other classes or other interfaces. Or in other words, you must use sealed interfaces and types somehow. Otherwise, you get a compiler error. And that's why, and that's what the syntax diagram is here about. For example, if you look in the line 1, non-sealed interface, you get a compiler error. And in the syntax diagram, you can see that you cannot start with a non-sealed type. So you must always start with a sealed type. And then the question is, what comes next? In some cases, you can skip the middle part of it and just one enum or one record or final class or some non-sealed type would be enough for the sealed type at the beginning. However, you can reseal and non-sealed types in case you need it, as you see in the middle. But in the end, you also then need types like enum records, final classes, or non-sealed that implement them or extend them. You can see on line 2 the sealed interface missing permit list. And as you notice, there is the command mostly compiler error. There is that case that not many people have heard of, where if you put all the interface, the sealed interface with all its implementation and other types in the same class, you don't need to use a permit list. If you, however, put them into separate class Java files, then you must always give a permit list. You can see a permit list in line 3, where we have the sealed interface or type sealed, and the sealed, and non-sealed. And in line 4, you see, for example, that you can reseal a type. You can also in line 5 unseal a type to be more flexible. Again, in line 6, you see a final class that implements seal. Wonderful. Also, records can always implement them without any unsealed or other thing, because records are by default final. And last but not least, we have line 8 and 9, and they lead to compiler errors in line 8, because we have to have a final class here or unseal it. And in line 9, as you see, but also an error, because in line 8, sorry, in line 8, you see that this unpermitted type is missing in all the permitted permit lists. That's why it's a compiler error. And in line 9, it's a compiler error because the class must either be non-sealed, sealed, or final. I hope that helps you to understand what sealed types are. And here we just focus on sealed interfaces, because records cannot be extended because they extend by default the abstract class record, and as they are also final by default, they can only implement interfaces, but not extend other types, no abstract classes. Okay, I hope that was not too difficult for you. Why pattern matching? Well, there is one observation that I made. And if you just look at those two examples for just a moment and just think about the layout of the code. Okay, I hope you clearly see that in the lines from 2 to 6, we have always some kind of diverging between input and output. You jump all the time between input and output. And if you have a long list of if and else if, it can be quite confusing if you always switch from input to output, and from input from output, it's quite alternating and might be quite confusing. With pattern matching, you have the great opportunity that you can somehow have a table with left the inputs on which to match, on the right the outputs. And that sometimes better fits in the screen, and it's much easier to read if you use it correctly. And how to use it, I will show you many examples just in some time, in a moment. I think if you not overload that in line 7 and 11 with too many patterns, I think it's often easier to read. Good. My examples all follow one basic example, and it's about Boolean expressions. So propositional logic, for those who study computer science or know from books about it. Why? Well, everybody of you developer every day sees and reads and codes if clauses and for loops, and they all have conditions, and all those conditions are Boolean expressions in the end. And I think that's why you are quite familiar with them, even if you had not much teaching in propositional logic. I decided to use the symbols from programming languages with the exclamation mark for not, the and the or, and also the short circuit operator, because you know that the 1 ampersand or 1 pipe character is actually a logical operation, a bit operation, while this double ampersand, double pipe symbol is, in my experience, more often used in code. And there are mathematical symbols, by the way, as well, but I fear that most people are not really familiar with them, except they had a lot of math where they get used to that symbol. Also, we really focus on these 3 logical operators. Also, there's NAND or imply and many other things, and we don't need them, but they exist, of course. Also keep in mind that we have a precedence here with the not, the ampersand, and the or, as in most programming languages, and we also can use brackets if we need to. And it's very important that, as you see here, with what it means, that it must always be clear, even without brackets, how to read an Boolean expression. I use all the time A, B, C, D, E for variables, and which are declared somewhere and are variables in the type of variable. And also keep in mind that this propositional logic could also be in your project in reality a small domain-specific language, also with operators and some operations. And so I think many things that I show you can also be quite useful with domain-specific languages. Last but not least, I must warn you, this approach that I show you is neither an approach with high performance or a lot of flexibility, for example, by grammar rules, which are quite common with compilers. And in these cases, I really can advise you to use professional tools like Endler4 by Terence Parr or YACC, so YACC, the compiler generator. Then use them. Try not to use this approach and optimize it extremely to somehow meet with the requirements. If performance and flexibility is very critical, don't use this approach that I show you. Otherwise, it can be very useful. Okay, just a small question here, because I'm just interested and curious. Who of you has heard about Endler4, even used it in a project? Just a short Y or a short N, or no? And if you just don't know it, you can also add a question mark to the chat. Oh, okay, interesting. Some have read it, some heard about it, but have never used it. I must confess that I also have not really used it yet, because I have not really invented a programming language or domain-specific language where you could really use it. But please keep it in mind, if performance is critical, flexibility is important. Okay. Thank you. Okay, let's start with the most simple problem that we might have from time to time. We would like to create expressions and define a short expression language, and we want to somehow display it. Just have a look on here, and I shortly show why this approach here, in my opinion, is better than just not declaring and implementing to a string in the records. And as you see in line 14 and 15, you see how it can look like. Just take your time. And for those who feel a bit that this is boring, you maybe noticed in the title that it is flawed. And just think of a moment why it is flawed. One moment, I'll be back in just a moment. And I think in line 15, it already spoils it. I'm back. Maybe you noticed the word Stadt. That's in English instead of, because I also have German slides. But you should see here that the toString method concatenates all those expressions in a confusing way. If I just switch back to one of the first slides, you see here, for example, that the default toString method is a bit too much, the string in line 16. And you would often like to have it shorter and not see the class names which are used, and the variable names and things like that. That's why we define it here, or we implement it. And you see here that just implementing toString in this way gives you a wrong output. I will show you now how you can fix that. And it is, as we are lucky, not so difficult. For example, you can do that here. Don't overlook that in line 4, I just omitted some records so that you really must focus on them here between line 5 and 15 on not and end. And just read it for a moment and try to understand why this solution here gives you the right output this way. Good. Maybe you noticed the magic trick in line G that we introduce brackets. And with brackets, we can make it explicit which expression we have. And as you see in line 18, now you get with the brackets the right expression. If you evaluate it in this way, you will get the right result. Okay, this is one way how you can create a string from that expression. But I told you before that we have the switch pattern matching, or the pattern matching with switch, and then it can look like this. I'm sorry, I noticed that I'm mute. Now, once again, you can see here that pattern matching with switch in the lines from 7 to 11. And I hope you notice here that it is more compact with the two string. And you also see here on the left side what the input is, and on the right side what the string representation should be. And don't overlook here that in 9, 10, and 11, we have some recursive calls so that we iterate over all the expressions and then really build up the swing expression, the output that we want to have. However, once again, it is flawed, as you see in the title. And actually, as you see here, it is the same problem that we face here. But we can also solve this problem in a very easy way. You can, for example, do this. Now you introduce the bracket, and the brackets are very useful. Okay, you see we have to add, of course, in line 9, a case for brackets. And it's very important here to keep in mind that we use that sealed type in line 1. And as you might notice, there is no default case in the pattern matching for switch between line 6 and 11. And that is the huge advantage of sealed types. By telling the compiler which types may implement that interface, the compiler can check whether you cover all cases. And if you cover all cases, then there is no need for a default case. This is different to the switch with ints or enums or strings. In this case, because I think they always need a default case, and they are much harder to use because you have to keep in mind the breaks and the spots. Okay, I see here a short question, and thank you for that. This two-string method here is an alternative to the two-string method implementations in the records. And this two-string here, I hope it is right, is also just a recursive call. So if you just look, for example, line 8, the call to two-string with unnegated ends up with the same two-string method, which we already use. Does this answer help you, Dan? If not,
Thanks. Hey, thanks for that. Yeah, I'm just looking at this from an old school Java perspective. So how does system out print line know that the two-string belongs to the expression?
Well, if you mean the system print line in line 15, you mean, right?
Yeah. So apologies. I'm
sorry. I completely understand. Here's a mistake on the slide. It should be two-string of expression and not just system out print line of the expression itself. I think that's what you mean. Wonderful. Thank you very much for telling me that. It's unfortunately that I sometimes overlook something.
No,
okay,
I
would just take a note of it and change it and then publish it. And thank you very much.
Thanks.
If I was Simon Roberts, I would say you have earned a brownie. Okay, thank you. And line 15. Where is two-string? That was on slide 11. Thank you very much. I really appreciate it. Okay. So I'm now certain that at least one really read all of the slide. The line 14. I think there's a semicolon missing. Okay, I understand your question, Victor. You mean on line 15 with the command that I could use more quote signs, but keep in mind that it is really a command and that makes it different. And if I had not a command here, I mean, would have to anyway somehow take care of the syntax rules of the Java programming language. But I must think of that. That is maybe a less confusing way for this command. I'll take a note of it. Thank you. You also earned a brownie. It is, to answer your question, whether it is one string or several strings, it is meant to be that it is in the end just one string. That's why I just used one quotes and not several quotes. But I must think about it, whether there's a better way to put it on the slide. If you, okay, but I hope the rest is still, yeah, that is what I meant then with the variables that I just omitted here because I don't have enough space on the slide to put it there, and that's why it's missing everywhere, and that's why I put it onto the first slide here, where I said that there are variables that I just use without showing you where I've declared it. Okay, good. Now this solution has must be corrected because it is flawed, and one way to do and maybe there's here one small thing missing. You know, the problem is that we have introduced brackets, but we don't use it on that page. Maybe you have noticed that. And the main reason for that is that if you have a pattern matching with switch, I strongly recommend, really strongly recommend you to focus on one aspect only. Because first, you will get many more cases if you try to cover several aspects at the same time. You might also become a problem of combinatorial explosions between the different aspects, and then have many cases, and it will become very confusing. And the switch pattern matching would become quite useless if it would become too complicated. So this is missing here. Sorry that it comes now. Just a small question, who of you need some more time, maybe 30 seconds, to understand all that much text on that page? Just a short Y or N. Of course, this slide is quite crowded with lines of codes. So I want to point out just there to ask in the chat for 10, 30 seconds more in case that you need it and we have the time. Okay, I don't see anything in the chat. I just assume now that you might have understand most of it, but I just shortly tell you what you should have noticed. The first thing is that you see in line 3 and 4, we have two cases which are nearly exactly the same, apart from the fact that once we use and once we use or. But it's even worse. What I told you with the combinatorial explosion is something that we can see in the lines from 5 to 10. You see here in the first example, we have two ors, then we just only have an or left, and we have just an or right. And if you now would not only have two operands, but 3 or 4, you can imagine that you get a cascade of cases. And this is quite ugly, in my opinion. And I would like to show you now 2 ways to simplify this pattern matching with quite trivial ideas. The first idea is, if we just focus on the not, that if we introduce here some types, then we can simplify this pattern matching. Okay, out I pointed out or I made some things here, or the types in bold letters. And the advantage of this type hierarchy here is that you can, I'm sorry, that if you look into line 10 to 15, you only have one case for the not. And it doesn't care anymore whether it's an and or an or, because it doesn't matter with not, because here you must add brackets, because the not refers just to the first operand, it refers to all of the expression. However, don't exaggerate, don't create type hierarchies with 3, 4, 5 levels. Don't do that. It's the same problem if you create a class hierarchy with a deep structure. This problem applies here as well. And if we just use a simple trick and introduce a parent parameter, we can make those 3 cases that we saw just a moment before also to one case. Just have a look here. Good. I hope you noticed that we somehow inversed the pattern matching in the way that instead of, as we did before, the construct the end for the ors, we do it here in the reverse order by just not asking what is in it, but asking in what is it. And the advantage here is that this approach can be also used in different situations as well. And I think it is quite effective and not very special. I want to also point out that something like brackets might be important if you want to have an output for a string. But I must warn you, don't add them if you don't need them. You will just show on the next slides that all the cases in the pattern matching would become more complicated if you really need to care about the brackets that you put into that expression. So we only need the brackets for the output as string, but not to process that expression. And so the brackets are somehow optional. Good. Now you might come with another feature and say, well, aren't there values like true and false in Boolean expressions? I mean, you not always just have only variables, and you also would like to represent it as well. And if you have only 2 values, and you will never have more than 2 values. Then you can just use an enum for that and just also implement the interface here as you see in line 3. Have a look on that. Good. As you see in line from 5 to 10, you just have to only add that case. Keep in mind that it would not compile if you don't add in line 7 that case, because the compiler would say the switch block doesn't cover all cases. And that's a way you can introduce it. So you can introduce constants with that here. Okay. You might now ask, well, wonderful that we can represent it, but for what? It would be nice if there's a way to evaluate that expression by inserting the Boolean values and then evaluating it. You can do it this way here. Good. Just a small comment. As you see here, the evaluate only works without brackets. And if you just would add brackets here, it would become quite complicated. You also see here that you somehow have a map with variables and values. And those values are used. This solution here has a small flaw that if you look into line 4, and if the get doesn't exist, you will end up in a null pointer exception, probably. And all those cases I want to point out have no checks in it for things if they go wrong. And you must think them or imagine them, because they would distract you on that slides here. That's the first reason why I put them not onto the slides. And the second, of course, my slides are not, I don't have enough space on the slides for that. But as you see here in line 14 and 15, you can use different configurations for evaluation. Good. Some people say the pattern matching with switch would make the visitor pattern somehow obsolete, which is, in my opinion, a misunderstanding. But first, I would like to know from you who has heard of the visitor pattern and has used it and has cursed about it. Can you just put it shortly to the chat? Why or no? Ah, okay, interesting. Yeah, that's a nice comment. If you say that there are many interpretations, and that's also the same experience I have made. I will show you now that the visitor pattern can be quite useful also with records. I only said that with the cursing that it is sometimes very difficult to understand how the visitor pattern works. I often have to think several minutes if I read code with the visitor pattern, how it is implemented. Okay. You see here in that interface that we start with a visitor. You also see from line 2 to 7 that for every expression we have a visit method. And unfortunately, we need in the line 8 to 16 default method to delegate the expression to the visit methods for the single expression types. Because there are situations where the compiler cannot know which visit method you actually need. And that's a case when you, for example, create a local variable of the type expression. And if you then just assign it to, for example, a variable, then this approach would really work only if your local variable would be of the type variable. But if it is from the type expression, it doesn't work. And usually you don't want to force the concrete type instead of the general type expression. And I think it would be very clumsy if you always have to know what actually your expression is. Good. This expression visitor comes quite handy. You might now ask, why do we want to have an expression visitor? And the answer to that is that this reminds me a bit of a problem that we have with state machines. If you just think a moment of state machines, you have on the one hand states and on the other hand operations on that state. If you have many states and you add another state, then you will maybe break code that have if then else clauses or switch cases on the existing states. And then you actually must maybe add this new state for all those methods that do something depending on the state. So this can become quite ugly. And also you might run into the problem that if you just use one methods that evaluate those things, and you will run into problems. And you might want to have with state machines of kind of transitions where you are flexible on adding new states and flexible on adding new operations without breaking all the states you already have. And this also applies to records, because if you, for example, go back once again to the first slides, if you have this, something like this here, then if you now add in the expression interface another method, and it's not a default method, then you actually must implement this method in all your records. If you have several records, this can become quite ugly. But this is only a problem if you add new states. And if you, however, use this approach here, adding new records and break this code here. And sometimes you need both. You need this here for one aspect and this here for another aspect. And then you run into the problem, what shall you do? The visitor pattern here can be used in this way here. Okay, thanks for having been here. Silent, I'm sorry, my pronunciation is bad. Okay, I hope you could understand what you can read here, but for those who had some difficulty, I just shortly explain it. In line 2, you see that you have one operation, and this except operation is just delegated to the visitor itself, as you see it, for example, in line 11. And this in line 11 applies to all records that you have. If you then also look on line 16, you see here, you always pass the expression visitor, and that one calls the write method, which handles the expression for itself. If you now look on this here, for example, you could add brackets here, I call it, so something to add brackets. And of course, this is an expression visitor that implements all those operations to deal with the expressions. And in the end, as you see here in the generic, it returns an expression, and this expression has brackets. Good. You see here that some methods just return what they have, for example, line 2 and 3. Then you have some methods, like in line 4 and 9, that somehow check the structure and then add brackets if they are needed. You can see that in line 6 and 7 for the not, that it checks actually whether there is a two-operand expression, like and or all. And you can also see in the end that it's not enough only to check whether the left side is in or. You also have to check whether the right side is also in or. And depending on that, you must use brackets on the left side or on the right side. But for some cases, like the or in line 15, it doesn't matter. Good. Well, now you might guess that if we put brackets to it, we might have something like a stringifier that creates us that string. And as you see here, it is quite trivial. It's actually the translation of the pattern matching for switch that we already had before, but now as a visitor. Good. Sorry if I change to the next slide so fast. Well, you're
Hey, Michael, have you got many more slides? I'm not sure if other people have got meetings and want to continue on a bit longer, but we are at time.
Yeah, I understand. I would just skip the last slide because it is too complicated.
Okay.
So I would finish in 5 minutes, okay?
Yeah, perfect.
The evaluator here, as you see here, does the same as a pattern matching for switch. And in the end, it could look like this, that you just create your bracket here, your stringify your evaluator. And you can add as many visitors as you want. and it's quite easy to add new records. And that's how you can use it. Okay, because we have not much time anymore, you can also use lists and generics. And just look on the examples in the Git repo and try them out if you want to understand them. I would now directly jump to the summary. Once again, really focus on one aspect. Don't try to be clever and deal with 2, 3, or 4 aspects at the same time. It will be a mess, no matter how clever you are. Also, deconstruct once. I mean, if you have decompose the structure of it, don't have too many nested in it, because this also makes it quite complicated. And that's a good comment to do that. It's very important that we have not permutations here. And that's a good observation. And if for the switch block, I can also say that sometimes, as you noticed before, you can just add a type and it helps you. Sometimes you can just use an additional parameter. You notice it can also help you a lot. Implicit per pattern, as I showed you before, can you get also more flexibility? Enums can be used for constants, records can be used for variables and composites. And this can have flat expressions and avoid deep expressions. And generic will give you some freedom on types. That's all, but it's not over yet, Kali, you know. And there's a second part of it. And this screams for a language where, or a domain language where you might have different notations, where you would like to check expressions, pass expressions from strings, simplify them, compile them to lambdas, things like that. This doesn't fit in this talk here. And that's why there's a second, there is a sequel. And it is on the 15th of February, right, Carly?
Sorry, what was that, Michael?
It is on the 15th of February.
Indeed, it is on the 15th of February. It'll be different Zoom details, so feel free to register on meetup.com. And yep, I'll be here hosting, you'll be here speaking, it'll all be good.
Wonderful.
Has anyone got any last? Yeah, perfect.
So you can find the slide and all code examples on that Git repo. Don't forget this password here. I don't like to share slides on the web without passwords. And enjoy it. And maybe I hope there's one or two, some tricks here that I showed you that might be very, very helpful, because from my experience, you hardly get always the time to experiment with several solutions. And we see here that this, I experimented with several solutions, and you can get quite nice solutions. But if you don't try it out, nobody's unfortunately a genius that he or she found always the best solution with the first draft. Thank you very much for your attention. Kali, I don't know, do you must to leave this meeting as well for the next meeting, or is there the chance for those who must go to the next meeting just leave and the others can just ask some questions if they want, if they have them?
If people have questions, we can stay for another few minutes. Does anyone have any questions?
Yeah, so nobody must be must have a bad conscience if he must leave, or she must leave. And for the others, just if you want to know something more about, have some questions, you know, there are no stupid questions, only stupid answers. And if you have no questions, but you still have some time, I would be very interested how you use records in the everyday business, in the everyday life. So any questions? I hope nobody is now overwhelmed or afraid to ask some questions.
That's okay. Is there somewhere people can reach you, Michael, if they want to digest, go through the slides and then come back with more questions?
Yeah, I unfortunately I cannot promise to answer all because sometimes I might not have a good answer or I somehow lack time. But if there is a question that you send me and it is somehow I'm somehow able to answer it without much effort, then I will answer that question.
Sure.
Okay, then thank you very much for hosting me, Carly. It was wonderful. I hope those who have stayed until the end were able to learn something which might be not useful at the moment, but in the future, because I think the records will be used in future more and more. And hopefully you will really get projects away from Java 8 or Java 11. But I'm quite optimistic because before we had that quiz about the Java versions at Paul, and there were many 70s records were introduced in Java 16. And that sounds quite promising for me. Okay, thank you very much. And
Cool. Thank you, everyone. Enjoy the rest of your day. Do sign up for Michael's next session on the 15th of February. There's some other LGC events announced as well. So take a look at the meetup page and sign up. And if you want to check the recording back afterwards as well, we will also make that available soon. And have a good day, everybody. Thank you. Bye.
bye.